Welcome to the unofficial Logic 2000 conditionals tutorial. Conditionals are a fundamental part of symbolic logic, and you'll be well advised to get thoroughly familiar with them. Being able to figure out which formula is or is not a conditional, and what the parts of a conditional are, is an especially important skill for doing derivations. So, what is a conditional? When doing derivations, we'll want to think of a conditional as a well-formed formula that's made up of three parts: an arrow, the part before the arrow, which we'll refer to as the antecedent, and the part after the arrow, which we'll refer to as the consequent. Now, please don't confuse the consequent with the conclusion. The consequent is the last part of a conditional, while the conclusion is the last part of an argument. They're both at the end of a three-part structure and both start with con, as does the word conditional. So they're easy to confuse, but you'll get the hang of using the right terms for them with practice. Now, back to conditionals. It's important to understand that the antecedent and consequent of a conditional can be any well-formed formula in official notation. For example, the antecedent can be P, and the consequent can be Q. Either the antecedent or consequent can also be more complex, well-formed formulas, like, say, P arrow Q arrow R. So let's look at some examples of conditionals within the parsing portion of Logic 2000. This is the most basic form of the conditional, and, as you'll know from doing the parsing homework, if you click on the main connective here, which is the arrow, it'll drop down into two parts: the antecedent, which in this case is P, and the consequent, which in this case is Q. Let's look at another one. Here there are two conditionals. When we click on the main connective, which for this problem is the first arrow, the formula will break down into two parts: the P, which is the antecedent, and the R arrow S, which is the consequent. In this case, the consequent itself is a conditional, which we can break down into an antecedent and consequent by clicking on the arrow. Let's look at one final example of a conditional. This formula is made up of three conditionals. There's the outer conditional and two inner conditionals. We can break up the outer conditional into the two inner ones by clicking the center arrow. In this case, T arrow Q is the antecedent and P arrow P is the consequent. Now it's a simple matter of breaking up the antecedent conditional into its antecedent and its consequent, and the consequent conditional into its antecedent and consequent. So from looking at these examples, we might suppose that every formula with an arrow in it is a conditional. In fact, that's not the case. Instead, the conditional, the three-part structure with an arrow, might make up just a part of the formula, but the entire formula itself might be something else. In Chapter 1, the only thing a well-formed formula with an arrow could be, other than a conditional, is a negation. Here's an example. This formula has an arrow in it, which means that part of it is a conditional, but the whole formula is a negation. You'll know from doing parsing that if you click on the arrow, it will turn red and not break down into two parts. You'll also know that in order to break this formula down, you'll have to click on the not or negation symbol. And that's how you'll know that this formula as a whole is a negation and not a conditional. However, it does have a conditional within it. But when we talk about the whole formula, we have to recognize that it's a negation. Let's take a look at another example. This formula is also a negation. This time there are two conditionals within negation. But you'll know that if you clicked on either one of these arrows, they'll turn red and not break up into two parts. You also know that here you'll have to click on the not sign in order to make the formula drop down, like so. And that's how you'll know that it's a negation. Let's take a look at one final example, and then we're done. Now, do you think that this whole formula is a conditional or a negation? You can pause the video here if you want to think about it. This whole formula is a conditional. The outermost connective in this formula is the middle arrow, which will break down this formula into the antecedent and consequent when we click on it. The antecedent and consequent, in this case, are both negations. We know that because for both the antecedent and the consequent, it is the outermost not sign that we'll have to click in order to make them drop down. Now we're left with two conditionals, which will break down into their antecedents and consequents. And then there's one final negation. Alright, that's it for now. I hope you now have a better grasp of conditionals, and I'll see you in the next tutorial.